Good afternoon, everyone, and welcome to today's webinar on Great Lakes shoreline restoration. My name is Trent Daavettila. I am the statewide engineer for CSI Geoturf. Also speaking today will be Steve Williams from Tensar in regards to the Triton Marine mattress. A little background on myself before we get going. I graduated from Michigan Tech University in 2008 with a bachelor's degree in civil engineering. I spent 8 years playing professional hockey and have obtained my PE license here in Michigan and have been with CSI Geoturf for over 2 years now. So for those of you not familiar with CSI Geoturf, we have been servicing the geosynthetic and erosion control industry for over 35 years and have grown into 3 locations: Highland, Byron Center, which is right near Grand Rapids, in Traverse City, and have become one of the leading suppliers of geosynthetics here in Michigan. We have a team of highly experienced technical sales representatives statewide, as well as an engineering design assistance department. So who do we service? Who does CSI work with on a day-to-day basis? We supply contractors performing work for governmental agencies such as MDOT, Eagle, the Army Corps. We also get involved with projects with contractors doing work for large private developers such as Ford, GM, Chrysler. And lastly, we get involved in projects servicing the energy industry and work with contractors doing work for ITC, DTE, and Consumers Energy. Today's agenda is to go over issues facing the Great Lakes shorelines, and then we'll look at ways to protect the shoreline, and we'll break it down into 3 different areas: tow protection, transition zone protection, slope protection and restoration, and close with a case study. So as many of you, I'm sure, are familiar, the Great Lakes are facing record high water levels, and this is causing the existing erosion control measures to no longer be sufficient. And these record high water levels are anticipated to continue in 2020. So if you look at the picture on the left, in the bottom corner on the left side, you'll see the water levels are almost over top of the existing boulder revetment, and the waves are now crashing right over it, hitting these dunes and eroding them. Here's another picture of sheet piling that was once an adequate tow protection, and now with the high water levels, the splashing's coming right over top of this sheet piling wall and causing the slope to slough off and continue to erode. So we're going to break it down into 3 different zones. When we looked at protecting these shorelines, we have the tow protection, where the waves are crashing, the transition zone protection, and then slope protection, where you're looking to get your vegetation established. Many of the products we go over today, we're just looking to plant ideas and different concepts in your mind. Some of these shorelines vary drastically depending on where you're at, where there's no one size fits all approach. So hopefully in today's, we get a lot of information to you, a lot of good information where you're able to take this concepts and ideas and utilize them. An example of tow protection: you have a property owner on the left who's protecting the tow with sheet piling, and their dune is in relatively good shape. And then you look at the properties to the right, where you can see the shoreline being eroded away consistently when there's no tow protection. The next area we'll look at, once your tow is protected, is the transition zone protection. So here we have 2 areas. Both of them have sheet piling, but the one circled in red, you can see the splashing of the waves is coming over the sheet piling, and the splashing is eroding the sand dune. Where on the right, where we have circled in green, you have some strong vegetation, a small tree even in place, and this is able to handle that splashing and the dune staying in good shape there. The next area we'll look at, once you've protected the tow, you've protected that transition zone, Now you're going to come back and protect the slope and establish vegetation. And so many of these properties have had the vegetation slough off and are going to need to be revegetated. So we'll look at some ways to do that. So as far as toe protection, the options that are pretty typical: boulder revetment on a heavy duty fabric, groins or jetties, or a sheet piling wall. Today we're going to look at the boulder revetment on a heavy duty fabric. So here's a photograph of a boulder wall being installed in place at the bottom of this dune to prevent further erosion. And you can see on the right, it's been placed on a heavy duty fabric. So why the fabric? Why is this necessary? This is going to prevent any of the boulders that you set down from settling into the sand dune and becoming ineffective. So the geosynthetic fabric's installed to keep these boulders from settling, as I mentioned. Here's a photograph where this dune has suffered severe erosion, but they've come in and installed additional boulder revetment on top of a non-woven. And as mentioned, this is that non-woven prevents any sand dune from migrating through the boulder, and then the boulder just being sucked into the slope itself, basically, and becoming ineffective. Here's another photograph of a non-woven fabric being installed underneath the Trent marine mattress, which will be talked about shortly. So once you've protected the toe, you need to look at the transition zone protection. And with that, I'd like to turn it over to Steve Williams from Tensar, and he'll speak on the Triton marine mattresses.
Thanks, Trent. Can you see my screen okay?
Yes.
Good. Appreciate that, Trent. My name is Steve Williams, and I'm the market manager with Tensar Corporation for marine and ports. And so most of my time is spent on coastal protection projects, living shoreline projects. So I handle Tensar's business in this market in the Western Hemisphere, but I also participate in projects all over the world. So I've already been on the phone today with Croatia and India, and interestingly enough, they're having some of the same issues in these countries in Europe and Asia and Africa that you're having there locally on the Great Lakes. And everybody is looking for new and innovative solutions, and that's what we're really here to dive into and see if there's a different way to help protect some of these shorelines than what we've seen in the past. So a real quick agenda. I'm only going to speak for about 30 minutes and then turn it back over to Trent, and he's going to finish it up there at the end. But we'll discuss coastal erosion and why it's important to understand the processes behind it. Dive into living shorelines really quickly and discuss some common applications that the Tensar marine mattress, the Triton marine mattress that we participate in. We'll look at a few interesting case studies that are kind of topical for the issues that are going on with the Great Lakes currently, and how this technology can help. And then we'll end it up looking a little bit at the testing and design methodology that we use when it comes to actually implementing these marine mattresses. So, coastal protection and people in the Great Lakes are obviously right in the teeth of this. But if we back up and we look at this big picture, over 60% of the US population lives in a coastal county. And even though they only make up about 10% of the landmass, and that number, the 60%, represents Great Lakes counties as well. So the Great Lakes, East Coast, Gulf Coast, and West Coast, most of the US population lives in a coastal county. So they're directly affected by sea level rise and the flooding that's occurring in the Great Lakes. Also, we see that that's a trend of a lot of people putting pressure in these areas, and that trend has been occurring since 1970. So over 35 million people in the US have moved into a coastal county away from the agrarian or inland areas and have decided to relocate to these areas because of increased opportunity, increased infrastructure. And what we see is that we're starting to put stress onto these coastal systems. First and foremost, we have over 60,000 miles of roadways are located in a coastal flood zone. So that represents a huge amount of infrastructure that that is vulnerable to coastal flooding, but is necessary to accommodate this migration of residents moving into these coastal areas. To dial it in a little bit further, over 4.2 million people reside within 2 miles of a Great Lakes shoreline. Obviously, what is coastal erosion? It's just a long-term or even a temporary redistribution of sediments along a coastline. In normal years, without flooding, you would see your beaches come and go and move naturally, and that's just a function of weather and prevailing winds and if you're on saltwater, tides. But in this case, I would venture to say it's because of flooding and storm damage. Michigan DOT recently released a study that they estimate over $100 million of damage has occurred to their system, and that's just DOT roads. That doesn't include local and county roads that they'll have to repair once these floodwaters go down. So what are the normal causes of coastal erosion? One of them is cross-shore sediment transport, which is just kind of a fancy way of saying the sand moving on and offshore as the year progresses. You don't really lose the sand out of the system. It just moves underwater, and then a storm might bring it back up on your beach. And it's just the natural movement of the sand off of a property line. There's also, however, littoral drift, which is when sand leaves the system due to longshore currents. And longshore currents are currents that move parallel to the shoreline. Once again, perfectly natural, and they're caused by prevailing winds. And they'll move sand off of your beach downstream, so to speak, and you lose that sand out of the system. However, typically you're going to gain sand into your system from property owners upstream. So usually, in most cases, it's a net zero, but when you have sea level rise or storms and flooding to contend with, which are other causes of natural erosion, it can cause the sand to leave your system, leave it in a hurry, and we're either left with a 20-year period where Mother Nature may heal it herself, or we oftentimes want it healed quicker, so we look to other measures to re-nourish our shoreline. However, not only do we have the natural processes, but we also have anthropogenic or man-induced causes. One of the biggest of these is the reduction of sediment supply. So over the years, as we have built dams and bulkheads, we've starved the system of its natural sediment budget. And so instead of these sediments leaving farmlands into rivers and dumping out into the Great Lakes and re-nourishing our beaches naturally, we have a cutoff, and our beaches aren't able to recover like they once were before these dams and bulkheads were built. So bulkheads are steel sheet pile walls. They also lock in the natural sediments that would, over the course of years, seep into the system and nourish our beaches. The bulkheads are cutting that natural sediment supply off. A few other causes that aren't necessarily something that we worry about, but one of the big ones is encroachment. And encroachment is just building in the wrong spot. And imprudent development, built too close to a beach profile or too close to a splash zone, or as Trent calls it, the transition zone. Even though it might give you a great view, or the house might have been there for the last 50 years, it doesn't necessarily mean that it was built in the best location when it comes to protecting the property from erosion. And sometimes it can actually exacerbate or increase the situation. So what do we do? So what are our options? How do we solve these issues? We got the issue, so let's solve it. Obviously, first and foremost, proper building setbacks. So people aren't building too close to the water. However, in a lot of cases, the property is already developed, and what do we do then? Well, one of those is retreat. And believe it or not, there are a number of states that no matter the cost of the property and no matter the value, they won't allow you to do anything along the shoreline, and the $10 million home will just fall into the sea. Obviously, that's not always very politically, it's not very politically viable. A lot of times it's not financially viable as we start to lose infrastructure. And it is a political hand grenade. So retreat is not necessarily always the best solution. Some of these are saltwater solutions like sand bypass at inlets that we don't necessarily need to deal with. But I have noticed more and more articles talking about beach renourishment on the Great Lakes as the Army Corps of Engineers dredges out navigation channels. They're starting to renourish some of the beaches there, which is a good thing. It adds protection. Also, dune restoration. That's going to be key in the upcoming years as the floodwaters will reside. We'll need to rebuild these dunes, which are one of Mother Nature's best tactics for coastal protection. And then us in the engineering and construction community, we're going to be looking at coastal structures and building some of these structures to help protect these properties from future damage. So how do we do that? You know, for years, we in the engineering community have lived on the right-hand side of this graphic where you see bulkheads and revetments. And those bulkheads and revetments are kind of meant to interrupt that natural sediment transport. In other words, they're meant to lock in the sand and the real estate behind them. But what we're seeing more and more in the coastal engineering community is moving to a softer, more approach that better mimics Mother Nature. And we're starting to see that actually some of these softer solutions, greener solutions, if you will, are actually more effective than the hardening or the armoring of our shorelines that we've been doing for the last 50 years. And I'll relate that back to a study that was done off the coast of North Carolina several years ago by a lady, actually a doctor by the name of Rachel Gitman. She studied about 689 properties that were affected by hurricane damage back in 2017. And what she discovered was really eye-opening because 37% of the properties she studied were protected by bulkheads or hard armor, but they suffered 97% of the damage. So I'll repeat that one more time just so it sinks in. 689 properties were affected by hurricane damage. 37% of those 689 were protected by bulkheads, but yet they suffered 97% of the damage. What she really discovered is that salt marshes and living shorelines and natural habitat creation actually helped prevent over $650 million of damage way back during Hurricane Sandy, even though a lot of those historic wetlands had been removed or destroyed over the previous decades. So insurance companies have started to take notice, and where insurance companies take notice, very quickly the construction community takes notice, is that maybe installing the bulkheads and things of that nature that we have in the past might not necessarily be the best solution. And I'll play you a quick video here, and hopefully it comes through clearly on your end of the line. But this was shot on Lake Ontario by the Army Corps of Engineers in the Buffalo District. And you can see the energy that these waves have as they hit this concrete bulkhead and they overtop it, and they cause overtopping damage back here in the splash zone. However, and I'm gonna hit pause, these same waves are hitting this rock revetment over here, and the rock revetment is absorbing all that energy, and you see very, very little splash, even though the top of this rock revetment is the same elevation as the top of the concrete bulkhead here. So look at the splash caused by the bulkhead and the rebound of the energy, which causes a lot of scour and losing of your beach right in this area. However, the revetment is just absorbing that energy, and we don't have any splash over it. So this is what coastal engineers are really paying attention to and starting to design, is softer, more natural type features that do a much better job of absorbing the energy, as opposed to just putting a bulkhead in, which is a lot of people's knee-jerk reaction. So what other applications are there out there that engineers are using to save shoreline? Well, obviously there's revetments. We just saw an example of that. We also look at littoral drift control, which are commonly referred to as groins. And groins lock in sand that is displaced due to longshore currents or the littoral drift. And so they prevent sand from leaving the system. And they keep sand locked in front of the property. However, in a lot of cases, if a property owner builds a groin, they're going to increase the scour on the properties further downstream. And they're going to rob those properties of the natural sediment transport that they would have currently seen. We also have breakwaters and living shorelines. So if you go down to the Gulf Coast and Florida and even up into North Carolina and Virginia, they are building these breakwaters and living shorelines all over the place to help reduce the wave energy, build back their beaches naturally, and create habitat for local aquatic wildlife. Then we have inlets and jetties, which do a lot of damage to our shorelines, but they are necessary for navigation and holding open our inlets for freight transport, recreational purposes, things of that nature as well. So an engineer, if he's presented with one of these challenges and an eroding shoreline, they're going to look to probably one of these three manuals. The first one being the HEC 23 or the U.S. Department of Transportation's bridge, scour, and instability countermeasure guidelines. So that book is filled with all sorts of different countermeasures that are used to stop shoreline erosion, bridge erosion, things of that nature. The Army Corps of Engineers has published the Coastal Engineering Manual, and there's literally hundreds of different solutions in this manual as well for stopping shoreline erosion. And then in Europe and Asia, there's a lot of the engineers there will use what's called the ROC manual. And a lot of the guidance in the ROC manual is very similar to what you'll see in the U.S. Army Corps of Engineers manual as well. And then in these manuals, they'll deal with all sorts of different design considerations that you're going to have to consider in your design. And the top 5 of these considerations are variables that a coastal engineer would deal with, like what is the wave climate, the height, the period, where are the prevailing winds coming from, so we know which way the waves are headed, what are the water levels, either future sea level rise or due to flooding or any kind of storm surge, take into account currents, location. And with that, they'll kind of consider what the length of the structure is going to be, what the crest elevation, spacing, and porosity. But 2 things that coastal engineers may or may not consider are the stability and the constructability of the solution. And those are just as important, if not more important, because we can have a great design, but if we don't consider the really poor soils that we're building it on, or the fact that it's not very constructible, so not a lot of contractors are going to have the skill set to build it, it does no good to have this wonderful design that is not able to be translated into a sound structure that's actually going to help property. So we're going to spend some time talking about stability and constructability using marine mattresses. So, the engineers that would be designing the foundations for these structures are the same engineers that are designing our roadways, they're designing our building foundations, and they're really good at it. However, they may not necessarily have the experience of dealing with construction in the water. So building a roadway is one thing, but building it in the water, you have to consider that you have zero visibility, that currents are going to be working against you, that you're going to have tides in salt water, but not necessarily in the Great Lakes, but depth of the seabed. So a contractor is going to install his solution in a completely different method if he's dealing with 2 feet of water versus 20 feet of water. the fact that you got scour that's going to occur during construction, which is going to move your aggregates or the stone around as you're placing it. And then last but not least, if an engineer comes up with a great design and that is very constructible, how do we verify that that's what actually was built? So the contractor may feel that he built what the engineer designed, and the engineer may feel that the contractor built it correctly. But how do we verify that when we have zero visibility and all these other issues working against us? And that's what some of the new technologies and solutions that we'll be talking about try to help alleviate that unknown and make the contractor and the engineer feel just a little bit better. So Trent briefly talked about filtration and using a heavy filter cloth or geotextile layer to provide separation between the large armor stone or the large boulder stone and the subgrade or the material that it sits on. And if you go to engineering school, they'll say, here's how you build a filtration layer properly. You put in a layer of sand and a layer of stone, then a layer of larger stone before you put in your armor stone. Or you could put in a geotextile. However, if you're building this, like this plan shows, in 20 feet of water that's moving, that you have zero visibility on a really steep slope, the engineer that designed this didn't do the contractor any favors. In fact, I'd say he set the contractor up to fail, because that is not a very constructible design underwater to provide a proper foundation for this revetment. So the engineering community has come up with different solutions. And what we typically see, and these are the most popular solutions that you'll see in this splash zone, in the either down at the toe or in the transition zone, are these solutions. Armor stone with a geotextile underneath it, as Trent talked about. ACB mats, which are articulated concrete block mats. Tetrapod concrete armor units, and the Triton, our product, the marine mattress, or as it's generically known, a polymeric marine mattress. So here you have an example of a revetment. You have to select the proper size and dimension of the stone. You have to count for all your geotechnicals or ground issues. Do you have adequate bearing capacity? Is global stability going to be an issue? Is settlement going to be an issue? You have to account for it. And then you have to provide the proper filtration layer or separation layer, which is the large geotextile that Trent talked about, or the aggregate layer that I showed you in the previous picture. That has to go in underneath this, or else the whole structure is just going to sink down into the subgrade over time. ACB mats, these are a very common solution, articulated concrete blocks. So you have these concrete blocks that are held together by a series of cables. Issue here is the subgrade has to be prepared to a smooth finish, which above the water line, that's great. Once you get below the water, it becomes incredibly difficult to prepare a smooth subgrade. You do have to provide a proper filtration layer, which means you have to lay a geotextile, which above water is great. Once you get into the water, it's a little more problematic because they want to act like a sail, plus they want to float. And depending on large project requirements, you may have to put in a drainage layer. Also, if you're putting these in underwater, they have to be fastened to each other. So each unit you put in has to be mechanically attached to the other unit, which means you're going to have a diver attaching these together. Tetrapod concrete armor units are just large concrete jacks that you used to play with when you were a kid. Very, very heavy, which means you need to prepare your subgrade to account for the weight of these structures. But above all, they're extremely expensive and extremely labor intensive to install. And that's kind of what brings us to the marine mattress. The marine mattress has advantages of all those systems, but you don't necessarily have to prepare your subgrade to a smooth finish. You can attach the geotextile directly to the bottom of the mattresses, like you see in these pictures. So that way it's installed at the same time the mattresses are. And then we can add an extension to the mattress for the geotextile, so that way the mattresses can be laid shingle style, one atop the other, and never have a break in the filtration layer or the layer of geotextile underneath the mattress. Here you can see close-up pictures of the mattress itself, it's made out of a geogrid material that's braided together with a very high strength braid. And if you see this mattress being lifted in the middle picture, it is roughly 12 to 13 tons. So that geogrid is very, very strong, very, very durable. It's made for cold weather applications, and it's made to operate in environments like you see on the Great Lakes. Here's a picture of the marine mattress being filled. And in this case, a contractor chose to fill the mattresses in his yard and had the mattresses transported to the job site via truck. In a lot of cases, you can fill the mattresses at the job site if you have adequate room. Most contractors will fill it at a remote location, put it onto a barge, and barge it to the project site. So it's very, very flexible in how you want to deal with filling the mattress with the aggregate stone that goes inside. It's whatever makes the most financial sense and is the most economically feasible. Some projects, the contractor even chooses to fill them in place. Very rarely does that make sense financially, but if it's the only way to do it, that's an option as well. And here you can see kind of a fabrication drawing of the mattresses. But the thing to point out here is the mattresses have individual cells within it to keep all of the stone evenly distributed. So that way, if you manufacture a 12-inch mattress, you know that you're getting 12 inches of coverage throughout the entire length of the mattress, which makes it much more verifiable by the engineer, even if they can't necessarily see it once it was installed. So let's take a look at a couple of case studies here real quick, and then I'll finish up and let Trent go. This is a project, even though it's located in New Jersey, is very, very, very similar in scope to what you would see on Lake Michigan or Lake Superior or Lake Huron. This project was constructed back in 1996 by the New Jersey Department of Environmental Protection, which is very similar to Eagle there in Michigan. And it was an emergency project where they had to put this revetment in to save some very sensitive wetlands areas behind it, as well as some old historic buildings. And these mattresses sat out there exposed to the direct surf and direct sunlight for about 10 years. And the Corps, the Army Corps of Engineers, came in and did a beach renourishment project. Roughly, see, it was 96, 2004 is when they put in the first beach renourishment. They came back in 2006 and finished it up. And as part of this, they kind of buried the mattresses, and the local stakeholders came in and planted dune grass on top of where the mattresses were and turned it into a living dune system. And so on the right, you see the pictures that I took out there at this job site back in 2019. Very, very healthy dune system that is hardened underneath it as a last line of defense to protect it from future storms. But I will mention that when Sandy hit this area, God, that was almost 10 years ago, 8 years ago, very, very little damage was done because this dune did a great job of protecting this area from any type of storm surge and wave action. Those mattresses out there, you know, they sit on the very southern tip of New Jersey, and they see, before they were covered, they saw anywhere from 5 to 10 foot waves on a regular basis, just because this is a very exposed area, and they performed great. Another area that would be very similar to what you're facing there on Lake Michigan is up in coastal Maine. So here we have the extremely cold weather and ice to deal with, as well as bluffs and large waves that we're trying to calm down using the mattress and take that energy out of it. So what I have here is two pictures of a living shoreline. The one on the left is, you can see the mattresses down there at the toe, and you can also see that slope. Well, that slope is a reinforced slope. There's turf reinforcement mat on there, and I think Trent's going to talk about some other solutions that can be used to stabilize and protect that slope. But the mattresses were used down at the toe for wave protection and to lock the toe in. And you can see the picture on the right. I'm standing there just to kind of give you a sense of scale. of how large those mattresses are and how tall that slope is. But this was after 2 nor'easters had hit this area with 5 to 10 foot waves and 3 to 4 feet of storm surge, and some of the vegetation was sucked out, which is fine. You can always go back in and replant vegetation. It's sacrificial. However, the slope did not fail during these large storms in this area. So it's another testament to the effectiveness of these mattresses operating in extreme cold weather, along with extreme marine conditions. I want to show one more quick video before we wrap it up, and that's this is from a project down in Florida in Panama City Beach in the Panhandle. And this area was hit by Hurricane Michael a couple of years ago. Hurricane Michael was the 3rd most intense hurricane ever to hit the United States. So yes, it was more intense than Katrina. The only reason we don't talk about it is not many people live in this area. So it didn't do as much property damage, obviously, as Katrina did. However, the winds were much more intense. And this area would have seen a lot of waves and a lot of storm surge. And I went down there to take some pictures of a project that was built approximately 5 years ago. So it had been in the water about 3 years before Hurricane Michael ever hit. So you see this rock breakwater and you see the marine mattresses that are located underneath it. These are pictures that were actually taken by drone during construction. And I was able to get out there with a small GoPro camera and actually dive around the edges of these rock breakwater structures to see how well the mattresses had performed and if they had done their job, which was scour protection on the leading edge or the outside edge of these structures. Obviously, they also provide some bearing capacity benefit, and they provide some benefit for reduction of settlement. But their main job is to provide filtration. So there's a geotextile layer underneath it, as well as providing scour protection for the outside toe of that structure. And there you can see some workers installing or pouring aggregate into the mattresses. So after the installation, here's some underwater pictures of the mattresses. This is after Hurricane Michael. And as you can see, the mattresses look great, no rips or tears. They're performing well. They're protecting the toe of the structure from scour. And here you can see that very large armor stone sitting right on top of it. And the best benefit is a lot of these fish have made this into their home. It's now a living reef, and it provides a lot of structure for and habitat for the local fishermen in this area. Last case study, this is another project in New Jersey. It's on a tidal river, but it's what we call a vegetated reinforced soil slope. And this slope is a 1 to 1.5, which is very, very steep, and uses Tensar geogrid as the primary and secondary reinforcement, which is a fancy way of saying the geogrid is holding this soil in place and locking it in place. And marine mattresses are used down at the toe to protect it from scour and provide a little additional bearing capacity here that's needed. So you can see how it's built using geogrid and then secondary layers of geogrid as well, then all wrapped. So here's a picture right after construction. You can see the marine mattresses at the lower level and the geogrid wrap on the next levels on that steep slope. This is a picture about 6 months after construction. So you can see already that the vegetation is beginning to grow and stabilize that slope. And here's a picture of that same area 2 years after construction. And you would never know that this slope had any kind of work done into it. It looks completely natural. It has stopped all of the erosion issues that were occurring in this area and the sloughing of the slope. And so it has solved an extreme maintenance issue for the local municipality to maintain this small marina area. We also do a lot of other applications, so it's not just shoreline protection. We really get into bridge scour and a number of other kind of fun things that I get to play around with. But this is a picture recently of a project in coastal New Jersey as well, where the mattresses were used in lieu of riprap or large stone underneath this bridge. It was a number of different reasons why the mattresses were selected: more environmentally friendly, easier installation, lower cost, less excavation or dredging, and the fact that the sand will accrete back on the top of it, and you'll barely know that the mattresses were ever there after the period. Works great, very, very high velocities coming through underneath this bridge, and the mattresses are working as planned. So with that being said, one of our best friends for using these mattresses is the Army Corps of Engineers. We've done hundreds of projects through the years with the Corps of Engineers. We've had hundreds, if not thousands, of other projects permitted by the Corps of Engineers. Needless to say, just due to the nature of our business, they're in coastal protection. If a project isn't designed and funded by the Corps of Engineers, it's going to be permitted by the Corps of Engineers. So one way or another, they get to touch it. And because they saw the benefit of using mattresses, they wrote a technical note on design guidance for the use of mattresses on Army Corps projects. And year in, year out, the United States Army Corps of Engineers is my largest customer. But not only did they see the benefit, we've gone in and done lots of laboratory testing on the effectiveness of using marine mattresses and developed guidance and methodology on how we design using marine mattresses. And we've taken that along with coastal engineering guidance, which is using that HEC 23 manual or the U.S. Army Corps of Engineers Coastal Protection Manual or the ROC manual, and we've distilled it down into our own tech notes using our laboratory data and empirical data we've gathered from the field, as well as that design guidance, and we've distilled that down into guidance for designing and using our marine mattresses. So they've been around for over 30 years, used on a number of extremely high profile projects up and down the East Coast, up and down the Mississippi River, even a few small projects up on the Great Lakes. And we're excited to be working with CSI on looking after, mitigation of some of these projects that are occurring, that are currently going on up there. And so with that, Trent, I'm going to turn it over to you. I appreciate the opportunity, and Trent, it's all yours.
Thanks, Steve.
And we can see your screen fine.
Okay, thanks. So now that we've looked at the tow protection, the transition zone protection, now we're going to look at slope protection and restoration. And with that, we'll get into Presto's, GeoWeb, Propex's Scour Lock, and Profile products. So Presto GeoWeb are 3D geocells used to confine soil. They stabilize and prevent the movement of unstable material. They're an extremely versatile product and can be used in various ways: load support, slope protection, channel protection, and retaining walls. So the GeoWeb was invented by the Army Corps of Engineers in the 1970s, and the original application was for military landings and beach roads. Some physical properties on the GeoWeb: it comes in different sizes, depths, and section lengths, and you can see the GeoWeb is perforated to allow the flow of water through it. The GeoWebs come on a pallet out to the job site, and the panels can be taken off and then installed. They stretch out much like an accordion would. The GeoWeb options we're going to review today are earth retention and slope protection. The first area we'll look at is earth retention. In the picture there, you'll see a GeoWeb gravity MSC wall. These gravity walls are typically good for up to around 5 to 6 feet tall. And you'll notice in the cross section on the right, you do want to embed the bottom 2 layers into the subgrade. And once you get over 6 feet tall, you're going to need a GeoGrid reinforcement. And in the picture there, you'll see the dozer spreading aggregate over the GeoGrid reinforcement and the GeoWeb face on the right side. These GeoWeb walls can be vegetated have an aggregate face or concrete face, depending on your situation. Some possible applications that we could see using the GeoWeb wall along the Great Lakes are installing in front of a steep slope, possibly infilling with concrete if you're a little ways back from the shoreline. You could use to handle significant grade changes where sandy slope is unstable, or you could use it to carry more gradual slope a lot longer and then go more vertical towards the end. Typically along the shoreline, the flatter you can make it, the less susceptible to erosion you are. So you can carry that more gradual slope a lot longer. So a typical erosion failure that I've seen along the Great Lakes are you have the old water level and then the new water level overwhelming the existing rock revetment. And then these waves are eating away at the toe of the slope, or the splashing and overflow is eating away at the face of this slope. Either way, you're getting erosion that's getting closer and closer to people's houses. So one way we could see utilizing this GeoWeb wall is, first of all, you place some additional boulders to help dissipate that wave energy and handle any ice action in the winter. And you could look at installing the Triton marine mattress then right behind that, and then get into the GeoWeb wall to protect that slope from any further erosion. So to summarize, the GeoWeb earth retentions, it's not the initial line of defense against waves, but can be a cost-effective solution for splash protection. It can be vegetated or unvegetated and utilized to prevent the further erosion of sandy slopes. The next way we'll look at utilizing the GeoWeb is in more of a slope protection aspect. So in this situation, you have a stable slope and you're installing the GeoWeb over the surface to prevent any erosion. You may need to install a geosynthetic layer under the GeoWeb, depending on what your infill is. And then the GeoWeb would be stretched out over top of that and either anchored in place using stakes or a dead man with a tendon attached to it. So the yellow is the tendon going down through the GeoWeb, and then it's tied off every third cell. If you are going to infill this with topsoil and vegetate it, you will need to install the proper erosion control measures until this vegetation is established. Being it along the Great Lakes, I'd like to look a little more into the anchoring options. The sand along the Great Lakes is not great for anchoring to. You may be able to get away with a longer stake or a duckbill anchor of sort, but what we see to be a more typical solution for anchoring is a dead man with the tendons at the top. So you go to the top of the slope and anchor it into some firm subgrade there, and then install the tendon and GeoWeb. The GeoWeb can be infilled with topsoil and vegetated, or aggregate, or even concrete. Along the Great Lakes, typically you're probably going to look at vegetation, or in some situations aggregate. Some possible applications I see for utilizing the GeoWeb would be to contain smaller stone behind the large boulders. Smaller stones are usually a lot cheaper, more economical. So the quicker you can transition from the large boulders to the smaller stone contained by the GeoWeb, the cheaper your project would be. You could look at using the GeoWeb infilling with topsoil to help vegetate and stabilize a steep sandy slope, or you can apply it to a slope to confine the sand even. Here's a photograph of the GeoWeb being installed behind a boulder revetment, and then it would be infilled with, as mentioned, maybe smaller stone if you're still going to see some waves or splashing, or vegetation if it's out of the splash zone completely. Here's a few photographs of the GeoWeb being vegetated. On the left, you'll see it shows you a good timeline. You cut the grade, then you install the GeoWeb, infill it with topsoil, and in that case, a TRM was installed to help prevent any erosion. And on the right, this is a project from along the Great Lakes up the slope a ways where you can't see the GeoWeb, but it was installed, infilled with topsoil, and then covered with a erosion control blanket. Typically along the Great Lakes, we recommend a straw coconut jute netting mulch erosion control blanket. It's historically been the most successful for establishing vegetation. So to summarize, the GeoWeb for slope protection, once again, it's not the first line of defense against waves, but can allow for steeper, stabilized slopes resistant to erosion, can limit undermining by confining the upper layer, and can be infilled with topsoil, local material, or even sand. Another product you could look at for slope protection would be Scour Lock by Propex. It's a combination of pure mat TRM and a non-woven geotextile. It's designed to handle bank stabilization along streams, lakes, and ponds. One thing I'd like to point out on the, excuse me, on the picture on the right is it shows it in the water, which is a good application for rivers, lakes, inland lakes, or streams. But along the Great Lakes, we see this product being more effective up the slope a ways and not susceptible to any huge waves or ice action or debris hitting up against it. Scour Lock is made up of metal baskets, galvanized steel, and each individual cube is 3 foot by 3 foot by 4 foot tall. And they come pre-assembled with the geotextile and then externally lined with pure mat. And each unit is 5 baskets hooked together, so they come 15 feet long. Here's what a typical cross section could look like for Scour Lock, where at the very start you install a geotextile, you put down a stone bedding for a working platform, and then the Scour Lock is installed, and they can be stacked on top of each other as necessary. And then you may need a dead man anchor going back into the slope depending on your design. The Scour Lock comes nicely compacted on a pallet, and then once the geotextile and aggregate have been installed, it can be easily installed, stretched out in place by 2 guys. In the bottom right, you'll see the dead man anchoring system was utilized on this project. And then the baskets can be filled with aggregate in situ soils, and then once they're filled, you can backfill behind them. And the pure mat face on these can be infilled with topsoil and vegetated for a green solution. So the advantage to this product is very easy to install and handle, can be filled with in situ soils, and has a very high strength pure mat face. The pure mat has a tensile strength of 4,000 pounds. It can handle 16 pounds per square foot of shear, which is equivalent to 36 inches of riprap. Some possible applications for this product are you can install in front of a steep sandy slope to prevent further erosion. You could use to handle splash from waves, maybe in lieu of additional large boulders. It could be more economical to transfer over to this. And once again, carry that more gradual slope a lot longer with an MSC wall at the end. Example cross section where you may utilize the Scour Lock would be similar to that GeoWeb wall where you have the high water levels overwhelming the existing revetment. So you install some additional boulders for that ice action and help with the wave energy. And then you transfer over to the Triton marine mattress and then close with the Scour Lock there to protect that slope. Here's a few photographs of the Scour Lock, all vegetated, looks very nice. To summarize, the Scour Lock's not the first line of defense against waves, but can be utilized to flatten out steep slopes, very easy to install, and can be infilled with local material. So once the toe's been protected, the transition zones has been protected, and you have the slope protected how you want, you got to look at establishing restoration on these slopes. With that, we go to profile and their hydraulically applied products. And the ones we're going to discuss today are Proganics, a spray on topsoil, Flexterra, a high performing erosion control protection, Proganics Dual, which is a combination of topsoil and a bonded fiber matrix. And then lastly, their Green Armor solution, which can handle concentrated flow. So who is Profile? For those of you not familiar, they're the largest manufacturer of hydraulically applied erosion control products, soil modifiers, and complementary accessories. And then their product lines are Profile Golf, Turf Athletics, and Erosion and Vegetative Solutions. So the first two products we'll look at is Proganics and Proganics Dual. Proganics is a spray-on topsoil alternative. It's very unique and a very good product for along the Great Lakes because of the sand, but it can be applied directly to sand or clay, and it's packed with nutrients, funguses, wood fibers, and other patented products, which basically, once you spray it on, will turn that sand into a topsoil for sustainable vegetation. Proganics Dual, which is a combination of the Proganics and an erosion control product, and can be applied up to a 2 horizontal, 1 vertical slope. So it takes a 2-step process and combines it into one. The next product I want to look at from Profile is Flexterra, high performing fleximum growth medium. It can outperform a double net mulch blanket. It uses chemical and mechanical bonding techniques to do this, and also promotes accelerated germination. Flexterra is made up of thermally refined wood fibers, water absorbents, 100% biodegradable, man-made fibers, and other patented products, and performs very well. Some of the statistics on its performance: it has no cure time and is effective upon application, can be installed on up to a 1-on-1 slope, and it has 1,700% water holding capacity, which leads to an 800% growth improvement factor. So all this leads to superior vegetation establishment. It has a functional longevity of 12 to 18 months. And it's 100% biodegradable, which makes it a good solution for along the Great Lakes shorelines. Here's a nice photograph showing how well the Flexterra bonds to the material it's sprayed over top of. You can see a chunk of this was ripped up, and the material below it is stuck to it. It's very critical that the Flexterra is applied at the proper application rate. Here's two pictures, one with the right rate, one without it. Very critical that it's installed at the right rate to be effective. Usually it's hit from two different directions, from the bottom of the slope and the top, or from 2 different sides. And a possible concept here, similar to what we're seeing along the Great Lakes, is you have this erosion going on, trees and grass sloughing off, and you can come coat this area with Proganics and then Flexterra to get vegetation going again to prevent any further erosion. In this situation, it doesn't show them protecting the toe, but it's the concept where you're getting vegetation established on your slope as quickly as you can. The last area I'd like to get in from Profile is their Green Armor system, which is a combination of a Futerra TRM and the Flexterra, which we just spoke about. So in this system, you install the TRM on the slope, and then you apply the Flexterra, and that gives it the immediate protection against any erosion, and then you get unmatched root reinforcement. So what this would look like, once the vegetation's been established, you can see how well the roots are intertwined into this TRM, which makes it a very strong against any erosion coming at it. And we'll Finish now with a case study at Concordia University along Lake Michigan in Wisconsin. The project was reconstructing a sandy bluff, which would be very similar on the Michigan side. So the problem was they had a 2 horizontal, 1 vertical, so very steep slope. They had uneven vegetation established, which was creating large gullies and further erosion. And it was all covered with invasive species with very poor root growth, which was causing sloughing. So the solution here was, number 1, remove all the invasive species. And then they installed the TRM, the first step in the green armor solution. You can see some platypus anchors were used because for the sandy material, sandy soils for getting good embedment. Step 3 was apply the Proganics seed and fertilizer for sustained growth, and then coat that with Flexterra for erosion protection. And then you have a beautiful green slope with even vegetation that's not susceptible to erosion. So to summarize, the Great Lakes are facing record high water levels, and we looked at toe protection, which was boulder revetment on a heavy duty non-woven fabric. Then we looked at the transition zone protection, and Steve Williams went over the Trent marine mattress. And then we talked about slope protection and restoration with the GeoWeb, Scour Lock, and Profile products. So once again, there's so many variations along the Great Lakes where there is no one size fits all, but a lot of the products we talked about, we're hoping to plant ideas in your mind. Maybe you can find good ways to utilize them and good ways to utilize them in an economic fashion. So with that, I'd like to thank everyone for attending. And just a reminder, we have 3 locations, Grand Rapids, Traverse City, and Highland. And we're here if you need help. If you want to talk over any products that you think may fit your project, we're very open to do so. And with that, we'll take a look at some questions that came in. There is one in regards to the price on the Tensar marine mattress. Steve, could you address that one?
Sure. And that's a tough question because the mattresses are a fabricated product that are made project by project, and depending on the size of the project and the complexity of the installation, are we doing it from a barge? Are we doing it from land? We have overhead clearances. Is it a contractor's first time? There's just a page with a list of variables that are on there to give a really good answer to that. So what I would do, if possible, there is punt the question and say, if you have a particular project that you're looking at and would like to get some pricing, please feel free to reach out to Trent or the guys at CSI. What I would say is that in a lot of cases, it's cost neutral to possibly putting down armor stone and lower cost than some of the other solutions that I looked at in there. So invite you to look at everything and all options and do what's best for your property. But I think the marine mattress stacks up pretty well.
Thanks, Steve. And I guess in that same regards, any of the other products that were gone over today, the GeoWeb for the MSE wall or Scour Lock, most of these are from an MSE wall standpoint, typically more cost effective than a concrete based wall. And then any other questions that have come in, we'll address by email. And with that, I'd like to thank everyone for attending, and feel free to reach out with any questions. Thanks, everyone. Thanks, Steve.
Thank you. Have a good afternoon.